Welcome to the last part of Competency 8 quiz. In this video, we will continue answering questions relating to exponential and logarithmic functions.
Number 11. Currently, the population of Appleville is 3,800. It is expected that the population growth will be exponential and that the population will be 8,550 in 6 years. What is the exponential rate of growth? Okay, let's identify some things off of this particular formula. The formula that we need is A equals A naught E to the RT. Okay, so we have A, this is our A right here. All right, let me move that down just a bit. RT, and then this will be our A. So that's going to equal the A because that was our future where we enter. And then 3,800, that's our A naught. Okay, do this one more time. All right, now our years is right here. So 6 equals our T. And our rate is our question. So R actually should equal X as our unknown. And that is what we need to put in the calculator. Okay, so what do we really need to do? In the calculator, we will have 8,550 equal to 3,800 e to the 6x. Okay, now you need to push math, arrow up. C is what we're about to use, the numeric solver. So push enter, clear out. Now this on the left is where we're going to start. We're going to start on the left side. So we have 8550, enter, and it pops us down, clear everything out. And now we need 3800. E is second and division. See the division symbol? Above that is our E. Now we carry it up, put in your 6x, and push graph. We may need to push it twice, so let's push it once. Okay, see, that's an old value. It's from a prior item, so push graph again. That's the value we need. Always remember to push twice. Okay, and when we round, we get B. Okay, notice I didn't calculate. I used my calculator for all that. That's what we have it for when we're testing. All right, number 12. The half value of an ingredient is a certain chemical is 15 hours of a certain chemical. Okay, the half-life of this ingredient, notice they did not say an amount for the ingredient. Let's keep reading. The percent of this ingredient has decayed after 7 hours. Notice they don't give it to you. We don't need it. Okay, so really what we have, sticking to the half-life formula, so it's A, and A naught's where we begin. But then we have the half, and that will be the, in this case, that is 7 over, actually what it is, it's time over the half-life, okay? But for our purposes, what do we need? Well, we don't need the A, and we don't need the A naught. This particular part right here, this gives us what is remaining, or percent remaining. Okay, but that's not what the question asked us. Okay, let me change my highlighter here. Let's go with something else. The question asked us what has decayed. Well, how can we put that in our calculator efficiently? We can say Well, our ingredient, let's say we have the whole amount. Okay, so we want the whole amount minus this percent remaining, okay, which is 1/2 with time. Do we have our time? Yes, we didn't even identify it. T is going to equal 7. So that will be 7. Try that one more time. That will be the 7 over the half-life. Well, we did not identify that either, but that just so happens to be the 15. 15 hours, that's our half-life. Now we can enter that in our calculator and it will give us the amount that has decayed. Okay, so let's go second mode, back out of everything, and let's just type it in. 1 minus parentheses alpha y equals, number 1 is what we want, of course, and then that's 1 over 2. You could have put in 0.5. Oops. See what I just did while I was talking? I deleted that out, and I'm going to arrow all the way over, put in my parentheses, which now I'm going to tell you, you could have put in 0.5, but we're not. We're going to type it in exactly how we wrote it. Okay, now carry it up, and again, we need alpha y equals number 1. Okay, but our values are 7 is our time, and our half-life is 15. Now, push enter, and this gives us a value, a decimal value, but it's not quite a percent yet. To make it a percent, let's say times 100, or just move over that decimal. And either way, you can tell by looking that A is what we need. Okay, now let's go to 13. Initially, there are 60 grams of radioactive isotope. After 9 days, only 20% of the isotope remains. What is the half-life of the isotope after isotope in days? Okay, what is it? Okay, what is the half-life of the isotope in days? Okay, so they're saying we just need the time. So what we need to identify everything and see what we're missing. Well, we're missing half-life. Okay, so our H will have to equal X in the calculator. So that's our X. Now, initially, well, obviously 60 is going to be our A naught. And after, our time has to be 9. Okay. But now our original, okay, they're giving it to us, our A, but we don't quite see it. They're saying only 20% of it remains. Okay, so what we have in the end, or rather our A, is going to equal the 60 grams times, because remember, we're calculating the remaining. Okay, so I'm going to turn that 20 to a decimal. All right, so now we have our A, we have our initial, we have time, we have everything that we need. So in our calculator, we will have 60 times 0.2 or 0.20, whichever one you want. Then our A is our 60. Now we put in our 1/2. And then we have a time of 9, and our H has to equal X. Okay, so let's put this in our solver. That's what we need to use for this. So push math, arrow up. C is what we need. It's highlighted, so push enter. Clear out, and we need 60 times 0.2. Okay, that's on our left. Now on our right. So if we push enter, it pops us down. Clear everything out. And I have 60. I'm going to put this in exactly how we wrote it out. Okay, type it in how you write it. Okay, parentheses open, alpha y equals number 1. Okay, 1, arrow down to 2. Now arrow over, close your parentheses. Pair it up. Now we need a fraction again. Alpha y equals, and enter. So we need 9 over x. 9, arrow down to our x. Okay, double check everything. Looks like it's entered correctly. Now let's push graph once and see what happens. That's an old value, as I warned you about. So push it again. And you know it's finished because it gives us a second bullet. Now let's round that. And it is B again that is our selection. 3.88 rounds perfectly. All right, let's move on. Number 14. The function h of x equals a to the x and is directly proportional to the first derivative. If h of 10 equals 5, what is the explicit expression for h of x? Okay, there's some information that is given to us that we're just not going to use. And that's this about the first derivative. We really don't need it for this particular situation. So let's take a look at it. Okay, we know that h of x equals a to the x. So this means that h of 10 equals a to the 10. We also know, or because it's given, that h of 10 equals 5. So what can we put in our calculator? We can put in our calculator a to the 10 equals 5. But you're like, okay, wait a second. We have an a. Huh? Well, that's just one variable. And because of that, a can just simply equal x. Big deal. So let's use math, caret up, enter, clear out everything, and let's say x to the 10, x caret up to the 10, press enter, clear everything out, and just put 5. Now, remember, you may have to push graph twice, so push it once. That's an old answer. Push it again. Now we have our answer rounded to 1.7. It's option D, 1.17 to the x. That's our a value. Okay, so that's what we were looking for. Now, number 15. Given k to the x equals a to the x, and the ratio of the functions k to the x to k prime x is equal to 2 over 5, what is the explicit expression of kx? Okay. All right, this is what we're going to have. First, we know that we need to set up something equal to 2 over 5. Okay, but we're told that it's a to the x to, kx to k prime x. So ax is the kx. So let's put ax there. And then prime, well, you have to know what the prime is of a to the x. Well, that is a to the x times ln a. Well, I see something that can be crossed out. A to the x over a to the x is 1. So this is what we have to put in the calculator. 1 over ln a equals, oh, I could type, here, let me write this just a little bit better. There we go. And 2 to the 5. So let's put this in the calculator. So we're going to have to back out, go again to solver, the numeric solver, push enter, clear everything out, and we want to set up a fraction. So alpha equals number 1, alpha y equals, okay? Then 1, arrow down, and now just push your ln, see your ln, literally ln, okay? And now instead of an a, we need to put x. Whenever you're down to one variable in your calculator, simply just put x. Okay, so x, I'm going to close my parentheses. Okay, now I push enter, pops me down, clear everything out, and say alpha y equals, I want number 1, and then that is 2 over the 5. I'm definitely going to have to push graph twice. So 1, 2, And there is my answer. And now let's select. That is 12.18 rounded. Okay, this is the last question in this particular video. Again, thank you very much for watching and liking us and sharing us and subscribing. You guys are the best. Happy testing, everybody.